truly honored to be here with you today. So, as Girish mentioned, in my role of worldwide tech leader, I look after the machine learning specialist solution architect function, all those experts that go out and help customers adopt AI and ML technology from AWS. I've been with the company close to 15 years now, so quite some time, and have seen quite a few exciting developments in all those years and participate in many interesting projects myself. In 1995, this is how the Amazon page looked like. Obviously, consistent with the styling of the day. But I want to draw your attention to one interesting feature here, right, which is personalization. From the very early days, we recognized that it's important to personalize the experiences for every customer. Now, I joined the company 10 years later, in 2005. So, with recommendations, you could say that Amazon actually wrote the book on this domain. I point you to an article which is 2 years old by now, but it was talking about 2 decades of recommender systems at Amazon. So very interesting read, detailing the different algorithms and item-to-item collaborative filtering, for example. So very important things to help you build recommendation systems. And you could say that, of course, all those experiences that we had supporting personalization led to Amazon Personalize, right, which is a service that we've launched sometime now. And it is my pleasure to actually announce that as of today, this service is available in AWS Mumbai region. But that's personalization. One of the very first projects that I've personally started with was search inside the book. I was responsible for building a search index that covered contents of the books, not just title, metadata, and so on. So we've literally scanned and OCR'd thousands of books. At those days, publishers didn't really preserve the PDFs sometimes, or electronic versions. We had to literally cut books into individual pages, scan them at multiple resolutions, and so on. And that enabled us to help customers discover books, not just by metadata, but by the actual contents. And back then, we were already interested in interesting natural language processing and information retrieval kind of features. So we've pioneered something called statistically improbable phrases. And the idea was that if a particular phrase appears rarely enough across an entire corpus of the books, but still appears more than one time, right? Appears in some books, that is interesting. And perhaps it relates to a topic that this book is about. And so if you expose this information as you're looking at a particular book, you could say, hey, web analytics application, I can click on that and find all other books that contain that statistically improbable phrase. And that was an early way of modeling topics for us, or yet another way of modeling topics based on the contents of those books. Now, the work that we've done for Search Inside, for extracting the contents of the books from the physical books, actually led to another important development. In 2007, we've launched Kindle. I was personally in the launch room back then, and that was exciting to see. This was, of course, the first version of the device, and we've had quite an evolution of devices by now. But you're seeing how all that experience is enabling us to then build on this and innovate and bring those innovations to customers. One of my next projects was Amazon Mobile. So I joined the team in 2007, and in fact, one of the first engineers on the team. And when we launched Amazon Remembers, Amazon Mobile, this is the shopping application on mobile devices. Back then, we've started with BlackBerry. In fact, you see a screenshot of what a BlackBerry screen would look like. But as soon as the iPhone SDK was opened up, we've switched our attention and launched an iPhone application as well. And one of those features that we've launched with was called Amazon Remembers. The idea was you take a photo with your phone of something, a product hopefully, and we will find that product for you and send you a link, obviously, to Amazon for you to be able to buy that product. When we launched this, it needed to be launched very quickly. It required a decent amount of accuracy, obviously. And it is a hard problem, right? You could have whatever you want in that picture and different resolutions, quality, and so on. And so when we launched this, we've actually did it with Amazon Mechanical Turk, which I'm sure many of you have heard about. So Mechanical Turk is often used for extracting kind of information, let's say from images like this one, right? What is the info? We call this artificial intelligence, right? Asking humans to perform so-called human intelligence tasks at scale and helping them earn money, and as well as simplifying this to many customers who publish those called human intelligence tasks. But as it turns out, in the modern day, Amazon Mechanical Turk is a very powerful tool for machine learning. It helps you label and tag your data sets. And these are human intelligence tasks that are published. You can go yourself and see what's published out there. You can become a publisher yourself and submit tasks. But this foundational work that started many years back led to innovations such as SageMaker Ground Truth, right? Which is allowing you to perform labeling of your data sets using Amazon Mechanical Turk or your own private workforce. If the data is sensitive, you don't want to expose it outside of your company, you can use a private workforce, or you can use some of the vendors out there who provide and integrate with the product. And this is one of the latest innovations with Ground Truth, where using an algorithm such as Dexter, it's becoming very easy to do image segmentation, right? Instead of having to draw a complete outline around the object, you just need to specify a few points, and the rest is done for you by the service. Here's a video of yet another feature that we've launched to simplify segmentation of complex images. So imagine where in something like this, you need to figure out which category, which class each pixel belongs in this picture. And so potentially very difficult for a human to spend a lot of time annotating. And what you could see is using these features by just selecting 4 key points around an object, kind of similar to what I've been showing before, we're able to quickly help someone label an image with segmentation. Obviously, this is important for a lot of applications, not just self-driving. Well, we also launched at re:Invent Augmented AI, which is related to this. In Augmented AI, or A2AI as we call it, you can start with a client application that needs to use machine learning model of some kind, right? And is requesting a prediction. It could be an AI service, a custom machine learning model on SageMaker. And As with all machine learning, we know that the accuracy may not be perfect, right? We need to deal with a situation where the accuracy or confidence in the result is not high enough. And so augmented AI allows you to handle exactly this use case. So if you have a high confidence result, fine. Send that result directly to the application. But if you're not certain about this, you can set up certain rules around the result and say, OK, I think I need to have a human look at it before I can actually make a decision. And so this is what augmented AI is there for, to do. You have, likewise, different types of workforces that are available for you to look at the images or look at the data, not necessarily images. And the results will be consolidated. We're also looking at the accuracy that human kind of reviewers produce as a result, right? And so we're able to curate and understand, OK, who is producing high confidence results so we can rely on them more and more in the future. And then results are saved, and of course, ultimately, both of these end up being used for decision making. And that's a key service that we've just introduced. OK, well, Mechanical Turk, great. But soon after this, we've actually enabled automated kind of product recognition, if you wish. Right? And so now, using your phone, the system scans a product and tries to identify it automatically and very quickly and efficiently for you. Remember, this is 2008, 2009 timeframe we're talking about, right? These kinds of experiences helped us launch services to our customers in the form of AWS. And of course, you've heard about Amazon Recognition, which allows us to analyze images and video and help customers extract useful information from there. And most recently, we've launched recognition custom labels. So of course, we have a deep variety of labels that are already built in and the models that are already there for you to detect certain kinds of objects. But there's always going to be that specialized kind of object that only you care about, right? And that's what custom labels is all about. So it's perhaps no wonder that with the variety and the depth of the capabilities that we offer, that customers are looking for AWS to build their AI and ML applications on top of. We have tens of thousands of customers who are using our machine learning and AI services. But the journey is just beginning, really, right? We're not done. We're far from done. And in fact, I like to think of this time as the era of steam engine, because we've started producing well-working applications that rely on artificial intelligence. And yet, when you look at academia and the research in the field and the understanding of the field, we still have ways to go. I mean, just think about one thing. There's not a single definition of intelligence out there that practitioners and researchers are working against. So it's almost like in the era of early steam engines, we understand that temperature helps us derive value, and yet we don't know what temperature actually is, that it is molecules bouncing around. Right? That's where we are in some ways. So exciting times, and I hope you're all excited to be here. And I'm sure that a lot of you are here, or probably wouldn't be here, right, if it wasn't for all those achievements in the field that sparked your interest and maybe allowed you to pivot your careers and look at AI and ML as a key important area to be working with and to be building an exciting future. So, AI and ML and the services that we offer are helping lower the barriers to entry dramatically. Think about the old days of photography, right? We don't really have to think too far back. Most of us probably experienced it ourselves, right? I remember developing film. But even earlier than that, right, this equipment is extremely costly. Very few had access to something like this. And today, it's just, you know, 1 meter away from you, right? Take a selfie. We're really dangerous with our devices. And people are producing incredible content with that, right? Not to mention all the bloggers out there, video bloggers, who are actually making careers and making living out of basically, you know, disrupting TV, right? We know it. So that is our goal. We want to make sure that we cater to machine learning practitioners of all levels of skill and all levels of experience. I have a PhD in this field. I defended it in 2007 while already being at Amazon. And back then, AI/ML was not as exciting as it is today. But my goal here is to show that with all the services that we have out there, with all the functionality, all the tooling, no PhD is required, right? You need to be a builder at heart, look at those opportunities, find examples, change them, modify them, put them in production, see what works, see what fails, iterate. So here's our machine learning stack. We necessarily take a layered approach to offering the variety of different services. And so if you're an experienced machine learning scientist, practitioner, you know your frameworks very well, you're actually coding the algorithms yourself, and all you need is powerful compute. You can launch an Amazon machine image with all the NVIDIA drivers, all the GPU drivers there, all the framework libraries there, and just go. That's available for you. A year ago, we've announced Inferentia, and at this re:Invent, we've actually launched Inf1 instance that's based on the Inferentia chip that people can start using and actually saving quite a bit of cost in inference. Remember that most of the cost in machine learning, ultimately in production, is running inference. And then on the top layer, we have AI services where, for the most part, you don't need a machine learning model to build, right? One is already built for you. So if you look at transcribe or poly or recognition, these services are at the API call away from you. The situation starts to blend a little bit with something like personalize and forecast, where these managed services help you build models that are custom to you based on your own custom data, but in a way that really doesn't require a lot of the domain-specific knowledge, so making it simpler. And at re:Invent, we also launched a few services such as Kendra, fraud detector, code guru, contact lens with Amazon Connect, and so on. And we'll be talking about some of these shortly. And of course, the middle layer, this is the very versatile layer where, using something like SageMaker, you can build a custom machine learning model workflow from start to end. This may appeal to experienced practitioners, scientists, but it could also appeal to talented developers who could just take a built-in algorithm or a sample notebook and use their own data to build and deploy a machine learning model and run it in production at scale. So these layers make it easy for you to build, make it easy for you to scale your machine learning, and, of course, make it easy to apply. And we'll be looking at each one of these layers in a little bit more detail. So looking at easier to build, most machine learning practitioners out there use Python. We know that, right? Python has become a de facto standard language for this. But when you talk to enterprises and look at the importance where different programming languages kind of occupy their space, Java is a very important language for the enterprise. I have a personal history here. I started learning Java as soon as it came out in '96. I had one of my first kind of job stints actually using the version 1.0 of Java. By '98, I was actually teaching Introduction to Computer Science and Programming in Java, replacing the curriculum in Pascal and so on, which was popular at the time. And in fact, today, James Gosling is at AWS, and I had a chance to meet him and thank him personally for helping kickstart my career, because I've spent quite a few years back then actually teaching Java and, of course, using Java. So when I came to Amazon in 2005, guess what was the dominant programming language in the company? It's not on the list. Not COBOL, but great guess. It was Perl. Perl. So while quite a bit of backend was already started to use Java, and of course there's still C++ there, Perl was the dominant language in the company. And of course, now things have completely changed. And you could see that Perl is not even on the list here. But I guess my point is this, that we somehow need to make it easy for all the investments in Java, right? And make it easy for those folks to build machine learning applications. And that's why we've actually launched Deep Java Library, right? That exposes APIs, provides an abstraction layer, and lets you do prototyping and building machine learning development using Java. So take a look at that. Just to take a use case or case from our own internal example, right? We have Amazon forecasting teams. And while the scientists on the team like to do things in Python, the actual production code is running in Java. And so a lot of effort is actually spent taking that Python code and transforming it into production code to run in Java. And so Deep Java Library is helping save 30% of effort in doing this. So I'm sure a lot of customers out there is going to be interested and will no doubt try Deep Java Library. But not just Java, look at SQL, right? There's great deals of investment in SQL across the board for many companies. There are many people who are wizards in this, right? They could probably write, deep nested joins in their sleep. So we want to make sure that folks like that are able to take advantage of machine learning as well. And what is the typical way of actually calling out predictions based on the data that's stored in the database? So the typical process kind of goes like this, right? First, you may have a model built perhaps out of the same data from the database, right? You extract it, you build the model. Then you need to write the application that reads the data from the database, reformats it in some way that it's able to send it to a production machine learning endpoint. And then once you get the results, you have to format it again and send it back to the output or to the ultimate application. All right, so these steps here, formatting, calling, not something that the database practitioners do, right? They know SQL. And so this is why we've released quite a few features to help these people access and unlock the power of machine learning right within their applications, right? So you can use, for example, Amazon Aurora and write a query that will hit a SageMaker endpoint directly. Same for comprehend. You can use Athena to marry the data that is extracted, let's say, from the underlying data lake and combine it with predictions in something like SageMaker, and similar for QuickSight. So now we're basically shortening this from 6 steps to really, 2-3 steps, because the model may already be there, right? And I'll talk more about autopilot in a moment, but you're just running a query and getting the results through your application directly. So here are some examples of the kinds of queries that you can run. Checking the transactions for being fraudulent, detecting the sentiment using comprehend, and so on and so forth. There's also some interesting features. I don't want to dwell too much time on this, spend too much time. But there's also batching going on where you may call the service with the first few rows, and then you get back the response, and then do some batching for the next 25 responses, and so on. Again, some interesting details, but of course, we're making it easier to use SQL and marry it with machine learning. All right. Now let's look at that middle layer, SageMaker. We've actually announced a SageMaker Studio, which is a complete integrated development environment. So for data scientists, you don't need to work within the AWS console, as great as it may be. We have, just like for developers who are used to IDEs, they do everything in the IDE. They're able to integrate with source repositories. They're able to debug things. They're able to build things. SageMaker Studio is that IDE that is available for machine learning practitioners. So here's an example, right? You may have your Jupyter Notebook with all the code, but right integrated with that, you can explore and understand the individual machine learning trials that are based on that notebook, based on the data that was used, and of course, look at the output in terms of nice visualizations. So we've also heard from customers that it's really important to be able to collaborate, right? Data scientists don't work alone. They could, but they prefer to collaborate. They prefer to bounce ideas off each other. This is no different than software engineering, right? You want to write code. You want your code review. You want other people to look at what you're doing. And so we're trying to make it easier for people to collaborate and share their ideas. And that's why we've also announced SageMaker Notebooks. Now, if you've used SageMaker up to today, you could launch a notebook, right? There's a notebook server that spins up. There is a URL that you go to, and you can then start and stop that notebook. And if you want maybe a notebook on a different instance, you may need to launch another notebook, right, and specify some additional details. Here, with SageMaker Notebooks, as a feature inside that Studio, you're able to provision your notebooks effectively in a serverless fashion. in a very simple, say, no explicit setup. And moreover, it's integrated with single sign-on in your company. So for example, you can provide your data science team a separate URL and a separate kind of place where they go to. They don't even need to know about the existence of AWS console. They just go to the studio. That's what they do for work, right? And you can have administrators deciding, OK, a new person joined the team. We need to provision that for them, so single sign-on integration as well. So there's fast startup for these notebooks. And you can create a shareable snapshot that incorporates all the dependencies, all the different libraries that were used to make that notebook operational, and you can share that with your colleague. And of course, with machine learning, you're doing many, many experiments. You're trying different things, right? You're maybe using different data sets. Let me run this algorithm on this data set, see what the result I get. Try a different algorithm, different data set, slightly modified, look at kind of current and historic data. And you need to be able to easily manage all this. How can you find out what kind of training have I done a month ago on this particular data set? Or what about my colleague, right? They're telling me that they've achieved these great results, this high accuracy. Let me look at what that is. And so that's why we're offering SageMaker Experiments, which allows you to search and compare the results of different experimentations. We have an abstraction, we have experiments, we have trials inside the experiment. So it's a way of organizing a data scientist's work or a machine learning practitioner's work. And then, of course, as you can imagine, there's metrics and logging and so on. So here's an example. For example, you can look at different trials within your experiment. You can have leaderboards saying, OK, this is the accuracy that I was getting when I ran these experiments. And as with everything at Amazon, there's an API behind this. So here's a visualization. But you can call the API and filter your experiments and build your own user interface on top of it if you needed to, right? So all these features are driven with APIs. And then debugging. Just like with software engineering, we need to understand what's going wrong, what happened when something failed. Machine learning is often, like these models are highly opaque. You're talking about neural networks with hundreds of layers out there. Complicated network topologies with tensors flowing around the network, and you're trying to understand what's going on. And that's why we've launched SageMaker Debugger, which helps us automatically detect errors and even set up rules that allow you to flag the errors, both in deep learning, neural networks, and an algorithm such as XGBoost, right, which is all about decision trees. So in this example here, we see that issues were automatically flagged for vanishing gradient and overfitting, which is a very common set of problems that ML folks face. Great. But we need to take the built model. We're happy with it. We see it producing awesome accuracy, and we deploy it. Even with auto-scaling enabled and creating a great endpoint, is the job done? So what happens is you need to monitor it, right? You need to understand, is my machine learning model producing the results that I expect? It was producing them when I trained it, but that was months ago. Right? So we've launched something called SageMaker Model Monitor, which is designed precisely for this. So you can set up kind of baselines in saying, hey, this is what I expect my machine learning model to produce. And you can set up visualizations, and rules and alerts that let you know that something is changing, right? And we know it's called concept drift in the industry. The conditions have changed. Your data doesn't look like what you used during training. You need to retrain the model, perhaps. That's a common answer. And so in this example, for churn prediction XGBoost dataset, for instance, there is one of the features in that data of whether customers have an international calling plan or not enabled on their devices. And so if you look at the overall sum of this metric, we kind of expected it to be this big, and we're seeing suddenly that there is a spike and things are changing. Okay, set up an alert, look at it, understand what's going on, and perhaps initiate a revision of the model, perhaps based on the latest data that you have. Okay. But with machine learning, you need to have the data. You need to know the algorithm that you're going to use. You need to know how to prepare the data before you pass it to machine learning algorithm. What else? You need to know hyperparameters, right? How do I configure the algorithm before it produces the ultimate result? All of these decisions, all of these things are not easy. That's why, you know, the folks are spending years studying and, you know, gaining the experience. And oftentimes you may know one particular algorithm really well, but have no idea about another one, right? And if you need to use that algorithm, you're starting from fresh. You're no different than anybody else who's just learning about that algorithm and how it works and how it, you know, addresses or attacks different data sets and the problems, how well it works in practice. So to help deal with the situation, you know, we've previously provided something called model tuning, which is the ability to search in the hyperparameter space and, given an algorithm, find out what is the best set of parameters that produces the best result. But often that's not enough. What about all the other questions, right? How do you prepare data? How do you choose the algorithm? That's not clear. And this is why automated machine learning is important. And that's why we've launched SageMaker Autopilot, which is trying to figure out all these decisions for you. And basically, you start with the data, and it goes off and searches through the space of different data preparation steps, different algorithms, different hyperparameters to produce the model that gives you the greatest results. So the one truly differentiating feature of Autopilot is that not only it does that for you, but it's not hiding that process. It's giving you access to the decisions that it's made and exposing a notebook that shows the kind of actions that it took. So you can understand the logic of what it was doing and say, okay, I think this makes sense, but based on my own personal experiences and intuitions, maybe I can even improve it by tweaking this a little bit, right? And so this is a great way of kind of sharing the automation and yet at the same time allowing for human experts to audit it and to improve it. And of course, it's integrated with the studio. So if you look at the tabular data source, there is an exploration and candidate generation job that gets kicked off. Then we look at different candidate notebooks and different trials to figure out what algorithm and data preparation is needed. There's, of course, an optimization happens that's very similar to the model tuning and Bayesian optimization. And then, based on your own kind of specification, it can kick off a great number of training and tuning jobs, and you decide how big of a space to explore. But at the end of the day, all of this orchestration is happening automatically for you. You start with a data set, say in a CSV file, and you decide on how much cost you're willing to spend on exploration, and then a practitioner is given the best model to go with. And then that person can understand the model and choose which of those actually works better for the use case. So for example, accuracy is not always the deciding factor, right? You may have a 9 meg model that is 95% accurate, but it takes a bigger latency, right, in producing responses. And often, latency may be the deciding factor for you, not the accuracy, right? And so you could say, actually, I'm going to choose this one, right? All right. So that's what automated model tuning is, SageMaker Autopilot is giving you. And all those trials are also automatically accessible inside the studio. You can look at each one of them. You can look at the hyperparameters. You can look at the results and go. So with all those things that I just talked about, just look at the number of features and functionalities that's in the SageMaker. Not just the Studio SD. Now we have a complete end-to-end workflow solution, letting you pick and choose the pieces that you need. So we talked about labeling. There's also machine learning marketplace. You can rely on models and algorithms that others have provided. They're built-in algorithms. There's training. There's reinforcement learning. So a couple of folks here at the conference who know very well about this domain. If you're interested, go talk to them. Neo, we haven't talked about, right? Compiling models to specific hardware, making optimizations, and of course, deploying and hosting. In fact, even before re:Invent, there are a few key announcements that were made, which are called pre-invent, that are really important, so I wanted to emphasize them. Right? There is, if you're using Kubernetes, we've actually provided SageMaker operators for Kubernetes. What if you manage hundreds or thousands of models? What if you need production endpoints for all these models? Launching a separate endpoint for each model is really not cost efficient. And we've heard this from customers quite a bit, and so that's why we've launched multimodel endpoints with SageMaker. So now you can literally deploy hundreds of models, maybe thousands of models onto the same endpoint, and you can decide and invoke all these models basically at the same time. So this is important because it's generating tremendous savings if you're using SageMaker at scale. And then we've heard from customers, well, there's great spot instances, right, that allow us to save a lot of money by launching sort of excess capacity in there. And there were some interesting technical challenges in allowing distributed training within SageMaker to happen on spot. So it took us some time to solve those challenges across the different set of algorithms. Because certainly all these algorithms were not conceived with spot in mind, where an instance could be taken away at a moment's notice, right? And you need to make sure that your training is not interrupted. And so that's why we have managed spot training that allows you to save, at times, 90% of cost for you. So definitely take a look at that. Cool. Moving on to the AI services, right? Let's look at some of these. Well, first of all, Contact Lens for Amazon Connect. You can use Comprehend to extract sentiment, for example. But this seems like an especially important thing when you have a customer service call or interaction, right? You want to know how happy or unhappy the customer is. There are many insights that you can gain through the flow of conversation, the pauses that happen. And so Contact Lens for Amazon Connect is really transforming this contact center kind of experience and insight. So, for example, given a particular conversation and the transcript, you can apply the sentiment to every single utterance, right, and see how the conversation went. You could detect, how it started and how it ended. You get sentiment both for the customer and for the agent. And importantly, you get certain categories that you can then tag against that contact trace record, and you could search and discover contacts like this. So very interesting, very important solution integrating machine learning into contact centers. The other problem that enterprises face is searching through lots and lots of documents that are generated. And I'm sure you're all familiar with that problem, right? Every company has lots and lots of documents that get produced at an increasing rate. There are different repositories of these documents, and you need to know, oh, for this content, I go here, and maybe this is the search system I'm using to search that repository. For that, maybe there's no search at all, and I just have to browse through and try to find stuff. But it's a very important area because a lot of productivity is wasted as a result of not finding the right information. So a lot of the data is really not well structured. So documents are documents, right? There's some text. There may be web pages. But, they're human written. And you need to extract some insights out of them. And keywords is not the great way to go, right? We all know that. And of course, like I said, lots of different kind of scattered data silos, different engines, and so on. So to help solve this problem, we've launched Amazon Kendra. And the idea behind Kendra is you are looking for an answer. You're not searching for a document, right? You're looking for knowledge or information, not documents. So there is natural language understanding and machine learning at its core, which, as the documents are being kind of ingested into the system and processed and analyzed into the system, is being applied to extract that information. There is some specialized domain expertise that is put to bear. And what's more important, that system is learning from the interactions that the employees at the company are using or are doing, searching for things. So WorkGrid is a Liberty Mutual company. And I like this quote, is that answers are not links. The real assistance is answers and action that you want to generate from that. And so an example that they've provided by using Kendra is very typical queries. We all care about some basic information, but it's often hard to find, right? So in this case, so Liberty IT, I believe, has a company internal kind of employee gym, right? And so if people are looking for some information in the system, you could see how easy it is to not find the right information, especially if it's sort of too specialized like this. And so what they've seen is by deploying something like Kendra, they get the right document which is sort of highlighting the right passage with the right information that's relevant to what you're asking. And then here's another question. Should I clean the machines? Well, what machines are you talking about, right? Cleaning machines. This could mean so many different things, and you know, Kendra is highlighting the right passage from the internal policy of using the gym. Okay, so that's enterprise search. We've talked about Java and software development. So how can machine learning help for that? In fact, speaking of Java, we have another person which is well known in the Java community. Arun Gupta is actually here, so come talk to him later in the session. But the software development process is you write code, you do code reviews, right? You build and test. You know, there's test-driven development, right? So oftentimes you write tests ahead of actually writing the software. You then deploy and you observe how your service, how your code is running in production. This is often a tricky part as well, understanding exactly how your code functions. And then you rinse and repeat. So the software development process has been well understood over years, right? There's so many software developers out here. But if you look at every one of these steps, there are difficulties. Writing code nowadays, you know, it's because so many different languages. Languages change all the time. Whatever is popular, whatever this client needs, right? How do I learn what is the best practice of this language? I go to Stack Overflow, I look at some answer, copy paste, great, off I go to the next problem to solve, right? You know it. Am I following the best practices at this point? Do I know? Am I sure I'm following the best practices? Maybe, but you really need to be an expert in the language and probably spend a lot of time coding before you feel comfortable. Yeah, I think this code is solid, you know, I can be sure. And so writing code and then finding that expert to review your code is also difficult. How do you find that person, right? And then once you produce code, how is it actually running in practice? I thought I wrote this awesome code, but it's so slow. What do I do? I mean, I just blame it on the hardware that we have, right? I probably need to upgrade the instance to have more memory and more power, right? Could be a solution, but there probably is something wrong in the code. There's probably a way to improve it. And so, you know, there are expensive lines of code that you could help identify. And so all of these things are important. And actually, it's interesting. Can you use machine learning for this? Can you have machine learning improve the process? And we believe so, right? This is why we launched Amazon Code Guru. And it does automated code reviews with sort of intelligent recommendations for what needs to be fixed. And then it also looks at the code profiling and the most expensive lines of code that are running in production. So just to give you an example, the first step for you to do is integrate with an existing code repository. Right, so repo admin will say, hey, I'd like to associate Code Guru with this particular repository. And then as a pull request comes in, the hook enables Code Guru to review the source code and embed comments that go back to the submitter so that that person can iterate. Let's look at some specific examples. Well, actually, I guess that's the flow, and I think it does talk about some of the steps that are necessary in extracting the features, understanding the software that's actually written, understanding the flow of code. But we've seen how this could be done with various levels of code analysis. And then based on the experience of vast installed Java code base that we have at Amazon, and including the best practices, we can then apply machine learning to find the common patterns, the common mistakes that happen, and give you back the answer. So here's an example. What's wrong in this one? Well, it may not be obvious, because you may not know what repo is, but there could be some concurrency issue, right, between checking whether a key is there and actually extracting it. And so a recommendation there is, because it's a concurrent hash map, is not thread safe, you need to wrap it or you need to do some thread safe modification to this code. And in fact, here's a better version of where you get the key, right, and then return it later on. Here's another example. If you know Java, great. If you don't, no worries. But the synchronized keyword here is essentially locking the object that is being passed. And while it's locking it, no other thread could enter that same code section, locking on the very same object. And so effectively, we're doing some checks and saying, oh, if there is no value in this particular map, we'll create a default one, or we'll initialize it, right? Very common kind of pattern. But as we're doing all of this, we're probably trying to be too synchronized, if that's a word. Right? And so a recommendation here is we can remove the synchronization and use put if absent instead. And so here is a more concurrent, if you wish, way of doing the same thing. All right. Some more examples here. You're doing a database scan, and maybe in your initial prototype, this was good enough, right? You got some results and you were happy. But you, in fact, forgot that often there's pagination involved, right? And you're not really fetching all the results. You're just fetching the first few. And so the recommendation would tell you to go back and fetch the rest. And here's yet another example where you're extracting AWS account ID, which is not something you may want to end up in logs, right? If an exception happens, this is potentially sensitive information. And often the exceptions contain that data. So if you print stuff in the logs, that will happen. And so CodeGuru can detect this. And there's a way to remedy with using something like redact by removing the sensitive information. Cool. So what I've shown you is all the examples that our machine learning and AI stack is kind of enabling We've seen how easy it is to build stuff, scale, and apply. And I wanted to throw in an example of me using something, just trying something out because I know some technique and how easy it is to achieve some results with this. So in fact, I went ahead and used a built-in algorithm called blazing text. This is built into SageMaker. And in fact, it's an improvement over Word2Vec running in a potentially clustered or cloud environment. And the exciting thing is, you can actually talk to Saurabh. He's here somewhere at the conference, right? And I just wanted to emphasize that there are many key people who are here. Take your time to talk to them. Take your time to shake the hands and listen, right? We have the general manager of vertical AI services here, Ankur. We have a GM of language services, Vikram. We have many PMs that are here. So go and talk to them. This is really a unique and exciting opportunity for all these folks to be here and sharing kind of their learnings with you. But speaking of blazing text, what I wanted to do is compute the word embedding on Hindi. This is not the language I speak, not the language I read, but it's interesting to see how these algorithms are, extracting insights and extracting semantics of a language and allowing a person like myself, who's not the user of the language, to see this and to then build on top of this. So what I've done is I've taken the entire corpus of Wikipedia in Hindi, downloaded it, and applied blazing text to that corpus. What that means is we're trying to compute the word embedding, which is transforming every word in that corpus in Hindi to a 100-dimensional space. So every word now is a point. And if you look at that space, the words that are semantically close to each other and are used in similar contexts would actually end up, by virtue of this algorithm, close together in that space. So I can examine the results and see, oh, the system is actually realizing something about these words that are actually very similar. So here are some of the 400 most frequent words that are in that corpus. And when you compute a 100-dimensional embedding, well, it would be nice to display a 100-dimensional kind of graph and explore that space, but it's not easy, right? So there's another step where you can actually compress it down to 2 dimensions with TSNE plot, and that's what I've done here. Now, my other challenge is looking at a plot like this in 2 dimensions in a language that I don't speak is going to be very difficult in trying to ascertain what these groupings are. So I've used Amazon Translate, and instead of labeling with the original Hindi words, I labeled with their English translations just to make it easy for me. And so here's an example on a kind of a blow-up version of some of that space. And here are some interesting finds that the algorithm discovered. The concept of family, birth, death, there's some relationship there, and you could see that these words are clustered together in one corner of that space. We see a notion of kind of nationhood, different countries, and a kind of a curiosity. There's a word combined, which actually is the same as united, so it was talking about United States, right? US and American, obviously very close together. And sports, games, cricket, team against, again, another cluster that's obviously fitting together. So this is how easy it is, right? You don't need to have a degree. You just grab an algorithm, take the data, and produce some interesting results on which you can build on. If you want to learn more details, there's an actual YouTube video that talks about the details of how to do it on any language that you can grab out there. And if you think Word2Vec is old news, What about BERT, right? What about all these NLP options that we have now? Well, in fact, we have some interesting results with BERT. So if you take P3DN24XL, which is an instance that has 100 gigabits networking and has 8 GPUs, it takes 9 days to train on that one machine, the BERT large model. You can then try to throw more GPUs at it, right? So as I'm adding more, the training time gets reduced to, I think, about 14 hours, which is now much more reasonable, but still quite long. And we can then take the so-called elastic fabric adapter, which is bypassing OS in between the nodes and making communication for kind of HPC or machine learning kind of clusters very fast. You could see that with that addition and an optimized TensorFlow for elastic fabric adapter, we're dropping this time from 14 to maybe 8, 9 hours, so faster. But with elastic fabric adapter, you can extend this to even more GPUs. In the previous graph, that wasn't possible. The more GPUs you throw, it just costs you more without much results. So I'm happy to report that we now have a record for training the BERT large model in cloud. Because with this, you can train it in 1 hour and 2 minutes. So the sky is the limit with what's possible with the technology and tools that we're offering. And with that, I thank you for your attention.